and welcome. This is Safa. Today we'll walk through the step-by-step process of designing a sliding mode control law. Let's dive in. The goal of our SMC law is twofold. First, drive the system's trajectory toward the sliding surface, and second, ensure it stays on that surface, even in the presence of uncertainties. The general form of a sliding mode control has two parts. The equivalent control, which keeps the system on the surface, and the nonlinear switching term, which brings the state to the surface. The design process follows these four steps. First, we define our sliding surface, then take it derivation. We set the derivation equal to a stable dynamics like negative sign of S, and finally solve for the control input U. Okay, let's consider a basic second order system. Our error is a difference between actual and desired position and velocity. The sliding surface is a combination of error and derivative. We derive the control input by taking a derivative of the sliding surface and substituting system dynamics. Then we enforce stable dynamics on a start and solve for U. Okay. Okay, let's go to MATLAB. We implement the derived SMC law in MATLAB. We simulate a second order system starting as position 5. The control derives it to the desired position 0 and compensates for any initial error or velocity. Okay. Desired position, desired velocity, initial condition, 4, and plot. Okay, let's run the code and look at the position over time. Okay. System response with a basic SMC. Okay, to recap, we derived a simple but powerful controller using this MC method. It's a robust and easy to implement for basic systems. In the next video, we'll see how it behaves under disturbances. Thanks for watching. This is Safa. We're learning together one concept, one line of code at a time.